A very scintillating afternoon to everyone present here and to those who have joined us virtually. Welcome is the best cheer. And I, on behalf of the PG and Research Department of Mathematics SFRC, welcome you all with a hard cheer to this session. Leaders instill in their people a hope for success and a belief in themselves. Positive leaders empower people to accomplish their goals. Our guest of honor and speaker today is a living example of it. And to introduce such an eminent person, may I now please invite Dr. R. Malini Devi, Associate Professor, PG and Research Department of Mathematics.
Good afternoon. Good afternoon, one and all present here. On behalf of PG and Research Department of Mathematics, SFR College, I welcome our resource person and all faculty members and students from ANJAC College and RIT and SFR College for this 3-day international conference on Analysis and Number Theory 2022. It's my great pleasure to introduce our enthusiastic chief guest, Dr. C. Durairajan, Associate Professor, Department of Mathematics, Bharathidasan University, Trichy. He completed his UG and PG degree program in Government College, Kumbakonam, MPhil degree in Bharathidasan University, Trichy, and also PhD in IIT Kanpur. He had 25 years of teaching and research experience. His area of specialization is mathematical coding theory. And he also published many research papers in both national and international level journals. Under his guidance, 8 PhD and 38 MPhil scholars completed their research. He organized many conferences, seminars, workshops, and refresher courses. Adding feathers to his hat, he worked as an associate professor in the Arab Mensch University, Ethiopia, and also presented paper at National Chittagong University, Taiwan. He is a life member of professional bodies like Ramanujam Mathematical Society, Cryptographical Research Society of India, Academy of Discrete Mathematics and Application. He completed 2 funded research projects, one from DST New Delhi for 1.01 lakhs on the topic on covering radius of some optimal codes and covering codes, and another one from CSIR New Delhi for 13.5 lakhs on this topic covering radius and various parameters of a ZQ simplex code and ZQ McDonald codes and covering codes. Ongoing projects from DST New Delhi for 6.6 lakhs on construction of new error correcting codes from graphs. Once again, I welcome you, sir. Over to you, sir. Thank you.
Good afternoon. Yeah, voice mic audio. Okay, no problem. First of all, I would like to thank the organizing committee members, management, organizing and management of ANJA, ROMCO and SRF colleges. Another my student now Professor in Mathematics, ANJAC College, Dr. Kannan, for asking me to give you a lecture. I told him, you can ask somebody else in our department itself. So, some unavoidable situation, they are not able to come. So, I came here to deliver a lecture. My talk is course from the incidence matrix of the graph. First of all, let us see what is code. What is the use of the code? Code is coding theory. It is an information theory. Sending message from one place to another place. How to send the message from one place to another place. Suppose one department to other department, we can ask one student, you go and tell this thing to the madam or teacher, then he informed to that, then we can communicate. That is different type. If it is far away from here, so over through phone or email, some electronic media. So those things are the olden days also difficulty, now also difficulty. The very 20, 30 years before, and there is, we are calling phone. That phone, from here to, if you wanted to talk in even Madras, we have to wait at least half day. We have to book the ticket, they are saying trunk call. We have to book the other exchange station, and from there it will take at least half day. You cannot imagine. You may be thinking that they are saying some false message. Because if you ask whoever crossed the 50, 55, they knows the difficulty. Even we cannot do it. So, you can imagine, even nowadays, even USA also within a fraction of a second we can call. So, the thing is, the message is, how to send the message, that is the difficult, that is the very problematic one. Because the olden day telegram is there, we can type whatever we are typing, the message will go through some connections. So, even olden days there are some cables. Nowadays the bifer cable, not bifer, optical cable has come. Olden days those are not there. Even 100 kilometers we cannot put one line. So, if we are putting a join, there will be interaction. So, whatever we are sending the message through some symbols, notations. The olden days they used to use the Morse code. Morse code is, they are using only 3 symbols. One is dot, another is dash, another is space. These 3 symbols they used to write all the things. Whatever they are sending the message, they using these symbols, they will send the message. It will go to the receiver end. The same thing they will decode, because whatever the equivalent symbols, the letters they will find out, they can write it, they can give the message. Even they don't know, is there anything wrong has happened, or is it right message or wrong message, that we cannot predict there. So for that purpose, later it has come through the satellite. We are sending the message through, even all the messages are, even our phone, immediately it is going to satellite. Even if I want to talk to somebody from here, through my phone, the message will be converted into a signal. Signal goes through the channels up to the satellite. Satellite receives the message, then it's sent to the exact persons. So the thing is, how these things are possible? Even satellites are far away from here, then it is going there, it is coming here, it will take time. No, they are nanosecond. It will be a fraction of a second, it will reach that, then immediately it will communicate. But before that, there are many processes are there. Whatever we are talking, that can be converted into a signal. Then it goes to satellite. Then it comes to the here. Then it will do. Before changing to the signal, there are a lot of processes on there. So, For example, if I wanted to talk in Hindi, you may not know that, but if you know, you can directly translate. Or somebody must be there to convert into Tamil or English. So for that purpose, even everything there is a language is there. Like Tamil language, Hindi, English, like the computer also there is a language. They are using the ASCII code. They are using every language there is an alphabet. There is an alphabet. Even computer language there are two alphabets. One symbol is 0, another symbol is 1. Even English letters, alphabet there are 26 letters. Similarly, all things. The letter, the symbol is not at all a matter to write any language. Even two symbols is more than sufficient to write anything. So, for example, now I wanted to say something. You can see that nowadays all the politicians knows almost English, other languages. Previously, some of the countries still they don't know English. If suppose our Prime Minister is going to some countries, in between there is one person, he is interpreter. He will convert whatever he is speaking, then he will explain to him, he will talk, then he translate to here. That is in the computer, it is compiler. Even when we are typing the computer, suppose I am typing 1 plus 2, you will see that is immediately the answer will be 1 plus 2 is 3. But computer don't know 1 plus 2. What is 1, what is plus, what is 2. So what the computer says, it has one language. It has one language. The one is converted into the ASCII code, plus also converted into ASCII code, 2 also converted into ASCII code. Thereafter, it will find the answer. Suppose you are speaking, for example, if suppose somebody is asking what is 8 by 7, 8 times 7, right? In the table, you are used to say 8 times 7. Like my age people, they cannot say that 8 times 7. Immediately we will convert. 8 56, we will convert, then we can see 56. Because those days we did not read that table. We are saying they used to wipe order. So even 55 crossing people, they have studied in Tamil only. So even if my daughter asks what is that 5 times 7, then I have to do convert into 5 like that I have to convert, then I will say that 35. Sometimes immediately I say that 35. Immediately my daughter, what is 35? Right? Then I will say 35, right? That type of thing is there. So computer what it do is, it converts into its language, then it convert to our language. That is compiler is there, then it will say 1 plus 2 equal to 3. So in between these things are happening. For that only the ASCII code, they are using ASCII code, they are using 2 symbols. The alphabet contains only 2 symbols. Similarly, suppose whatever we are talking, this has to convert into a language. Thereafter they have to convert into a signal. Then they will send to the satellite. Then only the signal receive the satellite receive the signal, then it transmit to the receiving end. So, if suppose I have an example, normally wherever I go I used to like you see here, this is the, suppose I can take this exam, standard exam, wherever I go I used to say this only. Suppose I have 4 messages. The message is called apple, banana, orange, grapes. You assume that only I have 4, right? And without assuming we cannot proceed in the mathematics, right? We always will assume that. I have only 2 symbols because apple, orange, banana, grapes. I am going to write in my language. My language has only 2, alphabet contains only 2 symbols. One is 0, another is 1. So what I did is, for every message I have written a string String means writing a symbol side by side. So, first message I have written 00, next 01, the next orange 10, crest 11 I have written. That is, 4 messages are there. I have written a string of length 2. String means writing the adjacent, right? The word. Length 2 means it is the number of symbols in that word. Right? 0, 0, 0, 1, 1, 0, 1, 1. So, now I am going to transmit through the oxygen, the journal. You see, our atmosphere is not perfect one. Even if I am speaking here, the backside people may not be understood because in between some interruption may be there, right? The interruption definitely affect the last bench people, last bench students. So like that, we are sending the signal through 2 satellite. In between storm, wind is there. If suppose raining is there, there is there because the signal goes like a air. Signal is like a air. So that signal, if rain may be there, the lightning is there, means it may be distorted or distorted. What will happen? The message cannot go as it is. The message cannot go as it is. Suppose I have sending 00 or 10 or 01, 11. It may be changed to something else. Something else means, suppose I am sending 00, I may be receive as 01, 10, 11. Immediately you can ask me that, why sir? 01, 10, 11. Maybe alpha, beta, gamma, something may be happened, right? That is not at all possible. Why? Suppose one person knows Tamil. He doesn't know any other language. If you dictate something, he will write. Definitely he will write. Something mistake means he will do in the Tamil mistake only. Right? You may say that Amma. Maybe the Nedil, Kuril, something that may be changed. Because he knows only Tamil letters, so mistake means some other Tamil letter maybe he written, right? Nothing else. Because of the in between A, B, C, D won't come, or some great letter, any other letter will not come. So, because he knows only that English Tamil alphabet. So whatever he write, the mistake Tamil letter only will come, not other letter. Similarly, 00 may be distorted. That message may be 10, 01, 11 it will come. Suppose the receiver, the satellite receiving that one, because of distortion, suppose I am receiving 10. Then the receiving end one person is there. He will decode the message. 10 means he will see that 10, it is orange. Immediately he says the message has come as orange. But we have sent apple, right? Why? There is no other option. He cannot think any other option. Because he received 10. Yes, 10. It is equivalent to orange. That's all. So this type, so whatever he cannot realize the error has occurred or not. For this thing, say, 1948, Claude Shannon. He is that person. He is a mathematician associated with electrical engineering. He realized that. So, messages, we are sending the message, we are not able to predict error occurred or not. After one day, one fine day, we are meeting, so I have sent this message. So, something he received, something else, like that we can discuss. But at the time of receiving, we cannot realize error occurred or not. What he did is, we have 4 messages. I have 2 symbols. My alphabet contains only 2 symbols. Length 2 I can write at most 4 possible ordered pair, right? I can get ordered, or string of length 2 I can get only 4. So what he realized is, we can increase the length one more. We can increase the length one more, like this one. Yeah. Instead of 0, 0, he added one more symbol. Not he added, we added, right? So he rehearsed like that only. So we can add one more extra symbols. Suppose we are sending the Apple transmit through noisy channels. Suppose we are receiving 100. Then he can see that the collection 000, 011, 101, 110. The 100 is not there in the collection. 100 is not there. 00 is there. 101 is there. 110 is there. 011 is there. There are 4 are there. That is one place. First one 3 places 0. Second one 2 places 1. Other place 0. Second, third, fourth. 1 place 0. Other places are 1 1. Right? There is now what we are receiving is this one. This 100 or 01111. These things are not there. He can realize that, oh, this is there. This type of word is not with us. This type of string is not with us. There we have strings 000, 101, 110, 011. But 100 is not there. So something error has occurred. Previously I told you we cannot realize error occurred or not. For this case, at least we can realize that error occurred. Error occurred, but we cannot predict this is on that point. So for that purpose, he added string extra. That previously I told you that this one, this is Apple is a message 00. I told you I am using 2 alphabet. I am writing a string that is a language word. So I have this is the possibilities. This apple, banana, orange, grapes are message that 00100111 are equivalent words in my language. Suppose I am saying namaste, vanakkam, right? That is equal, like equivalent, right? So these things are equivalent. This is we are calling source code. We are calling source code. Message is there, equivalent, that is like I told you, the English letter I, non, like that. It is equivalent one, that's all. That is we are calling source coding. That is we are calling source. The computer we are using the source coding. We are typing one, it is exactly equivalent one, machine language will come. Then it will do it, perform its work, then it will give the result to us. That is source coding. But after that we have added some more extra symbols to find out at least error has occurred or not. That is called channel coding. That's why I did not write apple is 00, orange is 10, banana is 01, next page is 11. But it is equivalent to this one, that's why I did not write, right? So this is equal after the 000, 011, 101, 110. This all called source coding. The previous one is source coding. Next one is channel coding. To find out the message, we are adding some extra symbols. That symbol is called check symbols. The thing is, sir, so we are saying that this error occurred, but how to correct it? That is a different. Okay, at least we must be very happy. We have detected the error. Previously, we cannot realize. Now we are realizing error has occurred. For that, what he did is we can add extra symbols, extra more symbols. You can see here. Now he added 3 more extra symbols. We have added 3 more extra symbols. Now we are sending the apple. Its source code is 00. Channel code is 00000. I am sending through the noisy communication channel. Satellite receive. After that, suppose we are receiving 1000 or any one place 1, other places are 0. Definitely we can detect the right code what we have sent. The method is we are calling nearest neighborhood decoding. Nearest neighborhood decoding means now I received, suppose I have received 1000. Now I am comparing with all code words. This is this 5 length strings are called code words. I am comparing with this one. You can see that this is the first one is I received 1. I am comparing with the first one. It differ only one place. If I compare with this one, it differ 5 places. First place here 0, here is 1. Here all other places are 0, here all other places are 1. So 5 places differ. You can see here 2 places differ. Here also 2 places differ. So only this place, only 1 place differ. So I can say that it is small. Differ means I can call it distance, right? So from this to the 0, 0 distance is 1. This is distance 5. Others are distance 2, 2, 2. So I can take the nearest means the smallest distance code word as here code I can decode, right? Now I am decoding this 1, 0, 0 into 0, 0, 0. This is a code word. So its source code is 0, 0. Its corresponding message is apple. So I can receive it. So you can ask me one error can correct more than that. This code cannot correct. This code, if any one error can correct, more than one error cannot correct. That I will come to later after, because this is only one place, other places are 0. If suppose I can take, you can see here, instead of 1, 0, 0, suppose received one is 1, 1, 0, 0, 0. Here, in this one, 2 places differ. Here, 1, 1, 4 places differ. Here, 3 places differ. Here, 1 place differ, right? Here, 1 place differ. This one is 1, 1, 0, 0. This is also 3, 3 differ, right? I don't want to take that one. So something else I can take it. Yeah. Instead of 1, 1, 0, I can take 1, 0, 1, 0, 0 I can take. 1, 0, 1, 0, 0 I can take. Here 2 places differ. Here 1, 0, 1, 0, 0. It is 3 distance. Here 1, 0, 1. Here 1 distance. Here 1, 0, 1. This also giving. So some of them may be give. What I am trying to tell is, some of them, if you go to more than one missing, one distance vector, it may be give 2 different code words for the same distance. Here, if one error occurs, only one code word give the minimum distance. If you go to more than one error, then at least 2 or more code words give the same distance. So that time we cannot do what we have to decode. Which one we have to choose. That is it is difficult. Even if we are sending the satellite to the Mars, the satellite it is taking some photos, they are sending us a digital. Then sometimes we cannot realize that what the satellites are sending the photos. Some of them we cannot predict it. This is equal to this one or that one. That time we can send, we can choose any one of them. Because we cannot we cannot ask the retransfer. Please send, your photo is not clear, you can send to me. We cannot ask. Space to this space means we can ask. So that time we have to choose one of them. We have to choose one of them. So that time that is the, even if you see our Indian scientists may say that the water is there in the Mars. So other scientists may say there is no water. Because due to this type of problem. Because here 2 error means some 2 code words the same distance will get. So I maybe choose one of them, this one. Some scientists may choose this one. So that type of error will happen in the satellite photos. Satellite photo we cannot say that this will happen. For that only there is a capacity. There is a capacity for each collection of the strings. The collection of strings I am going to call the code. The collection of strings after channel coding. After I have added some more extra symbols. That symbols are called check symbols or redundancy. So after adding this is I am calling code word. This is code word. This is code word. The collection is we are calling code words. So each word is we are going to call code words. The collection is code. This each element of the set is called code words. I am using two symbols, therefore now I am going to call binary code. If I am using the three symbols, you can ask me that is it possible, sir, 0, 1? Why not? 0, 1 we are using. Why don't we 0, 1, another one more simple alpha or 2, something else we can use it. There will be no problem, right? So if we use three symbols, we are calling ternary code. In general, we are calling query code. If we are using the Q symbols, we are calling query code. So now let me come to the mathematical things. This is not necessary. Okay, you can see here the previous one. This is first I used one. The C2 is I have first the source coding I have written. After that I have added one more symbol. That is this one. This is this one. Here you see that my alphabet F is alphabet. Alphabet is collection of symbols. That's all. Alphabet is collection of symbols. My alphabet contains only two symbols. These are the strings over F. Even if you know that one symbols, we can write infinitely many strings. So number of symbol is my alphabet contains, even you see that English alphabet only 26. Other Tamil more than 4, 5, 10 times, right? So, but letter is the number of symbols in the alphabet is not at all a problem. So, how to use? If it is 0 is there, only my alphabet contains 0. So, I can write a string 0. Next, another string is I can write 0, 0. Another strings I can write 0, 0, 3 times 0. Similarly, I can write infinitely many. I can give one of the equivalent word I can give. Equivalent message I can assign. So, number of symbol is not at all a problem. Here, similarly, this one. Here I am using three symbols. I have written a code word. This everything is, you can see that in this one, all the symbols are equal length. All the strings are 3, 3, 3, 3. Here also 3, 3. Here also 4, 4, 4. Each string contains exactly 3 symbols. Here 3 symbols. Here 4, 4 symbols. Right? So uniform length code word is called block codes. That is, the collection is I am calling code. The collection is I am calling code. Each element of the collection is called code words. Each code word has a uniform length. That is same length. That type of code is called block codes. Another is variable code. I will not go to that. This is not at all necessary. Okay. Now let me come to that. So our code means just a subset of. The mathematics, you are studying the vector space. This notation you may you can read this one. This may be you studied. This is n-dimensional vector space over R. Right? This means set of all n tuples over F. Set of all n tuples over x1, x2, etc. xn, such that xi belongs to F. This I can write bracket. Each symbol is separated by comma. This is this one. This is Fn, this one. Here you can see here the C2 is F I have written F3. C2 is subset of this one. If I remove F3, the comma, the bracket if I remove, then C2 is just a subset of F3. This one, the F, like Fn, F3. This is set of all 3 symbols, x1, x2, x3. String of length 3 over Fi, F. This one. So C2 is just a subset of. I have picked from here. I have picked up only 1, 2, 3, 4 words I have selected from here. This contains, F contains 2. Then this contains, how many are there? Each coordinate has 2 possibilities, the cardinality of this one. So 2 into 2 into 2, there are 8. Similarly, if I have a alphabet contain Q symbols, then Fn is a set of all Fqn is, each has a Q possibilities. So the cardinality of this is Q power n. Each has a Q possibilities. So total is n length, therefore Q power n. So it is just a subset of this one. My C2 is subset of F3. So this C3 is subset of, I take 0, 1, 2 is simple. This is C2 is subset of F4. So just now let me convert into like a mathematics. Why I am going to mathematics is, you see here I have used the one code. I told you to correct only one co-error. For that purpose I am going to use linear algebra. You see here, my alphabet I am going to take as a field. My alphabet I am going to take as a field. I told you 0, 1 I am going to use. Even 0, 1 is a field. Z2 is a field. Zp is a field if and only if P is a prime, right? That is there. In the BSc, maybe third year BSc, right? Zp is a field if and only if P is a prime. So now F2 is Z2. The addition and the multiplication must perform. Addition is addition modulo, multiplication is multiplication modulo 2, right? Similarly, now you can see here, yes, F2 I have taken a set of size Q code alphabet. I told you the string, how many symbols there are. If n symbols are there, we are saying the length of the string is n. Length of the code word is n. If it is a uniform length, so I am calling it the length of the code is n. I am going to say that. Length of the code is n. That is each code word length is n. That means a code of length n means it is a subset of Fqn. Each code word length is n. So you see here, C is a subset of C is a non-empty subset of Fqn. That is the collection. Previously we have seen that. Yeah. You see that this collection. Let me go here. Yeah, this collection is just a subset of F2, 3. This is collection of F3, 4. Just a subset, that's all, nothing else, right? You need not worry about the other things. So now I have taken this one. Now let me take my alphabet as a field, finite field with the Q symbols. My alphabet is a field, finite field with the Q symbols. So my code is a non-empty subset of Fqn. Fqn is a vector space over Fq. Fq is a n-dimensional vector space over Fq. Even small example for the vector space is F is vector space over F. F is a field, then F is a vector space over F. Fn is vector space over F, n-dimensional vector space. Similarly here, this is n-dimensional vector space over Fq. Fqn is a n-dimensional vector space over Fq. So, this I told you it is a subset of Fqn. Code is a subset of this one. If it is a, I have chosen subspace. Fq is a n-dimensional vector space. So, suppose C is a, instead of subset, if it is a subspace, then we are calling it as a linear code. Previously I told you code is a subset of Fqn. FQN is a vector space over F, n-dimensional vector space. So C, there is a possibilities for the subspace. If it is a subspace, we are calling it a linear code. So here, if C is subspace, then C is called a linear code. Then we know that if every vector space has a dimension, there is standard theorem. So subspace also automatically has a dimension. So C is a subspace of FQN, therefore there is a dimension. There is a basis, right? There is a basis. If we know the basis, then we can write that subspace or that the vector space. If suppose C is a subspace of FQN, its basis is U1, U2, etc., UK, then C is alpha 1 U1 plus alpha 2 UN, etc., alpha K UK. That is basis of C is U1, U2, etc., UK. Definitely K is less than or equal to N because dimension of FQN is N. So C is linear combination of alpha 1 U1 plus etc. plus alpha N alpha K UK. So that alpha I over the field FQ. So if we know the dimension, then we can say that what is the cardinality of C? Anybody can assume that? What is the cardinality of C? Dimension is K. We have taken because every subspace has a dimension. Every vector space has a dimension. So let us take the dimension of C is K. Then can you say that the cardinality of C? You see that there are U1, U2, etc., UK. That is fixed one, which is varying. Alpha is all varying, right? So alpha, how many possibilities are there? Each alpha has Q possibilities, FQ. There are Q elements. Therefore, the cardinality of C is Q times K. So, if we know that dimension, we can say that how many words are there or how many code words are there in C. So, I told you here, if C is a subspace of FQN, the code is called a code of length N we are calling. If you know the dimension K, so that is the dimension of the code. Next one parameter let me introduce. Yeah, you see here this is a linear code. Its dimension is 2. This is a ternary linear code. We are using 3 symbols here. There are 2 symbols. Yes. Okay. You can assume here the weight of X is number of non-zero coordinates. Weight of each code word is number of non-zero coordinates in that code word. The distance between two words. Distance between two words is number of places it differ. I told you we can check it comparing each pair. How many places it differ? We are calling the distance. The same thing I am saying here that. So the distance between X comma Y is number of places at which X and Y differ. That means if I take X minus Y, wherever the same, it will be 0. If differ, it is not equal to 0. Therefore, distance between X comma Y is same as weight of X minus Y. Weight of X minus Y. That's distance between 3, 4. This is there. Okay, next. This is the important parameter. The minimum distance of C is, I am comparing every pair of the words, finding the distance. In that I have picked up the minimum one. D of C is minimum distance between X comma Y belongs to C. X, Y are distinct. X not equal to Y. That's all. X not equal to Y. I can take two different pair of code words, comparing the finding the distance. In that I have picked up the minimum one. That is, suppose my C contains M code words, I have to check MC 2 pairs I have to check. MC 2 pair I have to check it. Find the distance between those, then I can find the minimum distance. So, this is called minimum distance. I told you length is the FQN, that is the length of the code word. If C is a linear code, then it has a dimension. Otherwise, the cardinalities I can write M. Cardinality of C is I can write M. The distances I can write D, minimum distance. Okay. Why I am using, I told you the previous code. So, these three you can keep in mind. Length is N, dimension is number of elements in the code is M, the distance is T. Previously we have used that. I told you that code will correct one error. Let me go a little back. Not this one. Okay, not this one. Let me go a little. Yeah, you see here, I told you the receiving message, if it is there is only one error to correct. You can see here the minimum distance between any two is, if we compare the first code word with the second one, the 4 place differ. First with the third one, 3 place differ. The second with the 4, 1, 2, 3 place differ. Next, third with the fourth one, 1, 2, 3, I think 4, huh? 1, 2, yes, 4. You see, this is the minimum distance of. So, what I did is, I have compared every pair and find out the distance. That is, there are 4 code words, 4C2 is, how many are there? 6. 1, 2, yes. I have compared 6 pairs, I have find out the distance. So, the minimum distance is 3. The minimum distance 3, I told you this code will correct any one error. That means, if you draw a sphere with radius 1, if you draw because the distance what I have defined, the distance between any two code words, that is a metric, because distance is always greater than or equal to 0. Symmetric means distance between x comma y is same as y comma x. Transitive, everything is true. The distance function is a metric function. If you know metric, we can draw a sphere. If you draw a sphere with radius 1 around this code words, around this 4 code words, the sphere never intersect. If you draw a sphere with the radius 1 around these code words, never intersect, because you see here, this is 1, right? The distance is 3. Minimum distance 3. So, I am drawing the sphere. This is one distance, they may be 3, 1, right? If I draw a sphere, I can draw here. This is 1 radius. This is 1 radius, 1 distance, right? This never intersect. These are 3, others are 4, far away, right? If I draw a sphere with radius 1, never intersect. So, whatever the message I have sent, if one error occurred means only one place differ. Either that belongs to either this sphere or this sphere or this sphere or this sphere, not both. Not both, because only one error occurred, it must belong to either here or here or here. Any one of this one. So I can decode as this is the message. I can say that this is the message. If it occurs more than one error, that time the received message may belongs to, because more error means this is, it may be overlapping there, because I am drawing a sphere with 1. Here is sphere with 1. So this is 1, it may be here, it is possible. So that time the received message belongs to 2 spheres. we cannot predict this one is right or that one is right. But we can choose arbitrarily if we are receiving message from the unknown persons. If it is known person, we can ask the retransmissions. So for that purpose only I told you this code will correct one error, because the minimum distance is 3. If you draw any sphere with 3 minus 1 by 2, the sphere never intersect. If your code has a minimum distance d minus 1 by 2 radius, if you draw the sphere with the radius this one, the sphere never intersect. Never intersect. So received code, instead of finding the minimum distance, the minimum weight is more than sufficient. Because you can see here, minimum of d of x comma y belongs to c, x not equal to y. Previously I told you distance between x comma y is same as weight of x minus y. So the minimum d of x comma y I can replace minimum weight of x minus y. xy belongs to c, x not equal to y. If c is a linear code, if x belongs to y, x belongs to c, y belongs to c, its difference also belongs to c. Its addition also belongs to c, because it is a linear code. Every linear property is true. Alpha times x plus beta times y belongs to c. If c is a subspace, I can take two elements from c, x comma y. Alpha times x plus beta times y also belongs to c. That is the best one. So here weight of x minus y, I can take x minus y is a c. So x minus y is as, we can check the weight of each code word, each non-zero code word. The minimum weight code word is the minimum distance. This is only possible in the linear code. So that purpose only I have taken that linear code. Here, this is some of the nearest neighborhood decoding. This is this one. This one is, and this is some example, right? That's all. What I told you is, if the code is, the length is n, if the dimension is k, the minimum distance is t, then this code will correct t minus 1 by 2. This may not be, we can take integral part, integer part only we can take it. I can write this notation. This many error can correct. So mathematics, the linear algebra plays the major role in the coding theory. So my topic is course from the graph theory. I can take 15 minutes. 20 more, okay. So because I have this time I have gone past, because I have to say that graph theory part. So that's why. So this is the thing, right? Okay. These things are I told you now. Distance between the minimum distance I told you d means, if you take comparing every pair of code words, it differ at least d places. It differ at least ரெண்டு கோட் வேர்டு கம்பேர் பண்ணீங்கனாக்கா மினிமம் டிஸ்டன்ஸ் d னாக்கா அதுல எத்தனை பிளேஸ் டிஃபரன்ஸ் இருக்குன்னா at least d places differ out. D or more places, that's all. At least, instead of saying at least, d or more places differ. So if you differ d places, d minus 1 error can correct using minimum distance decoding. Okay. Now, so the aim is, so how can we find some good code? Is it possible to find the good code from the incidence matrix of the graph? I told you here C is a, I can take C is a linear code. So it has a basis. Just let me take you can see that this one, the example 2, this is a linear code. Its basis is 0, 0, 1, I can write little bit 0, 0, 1, 1, 1. So another I am going to take, because you see here there are 4 code words are there. Its dimension is obviously 2. If it is a linear code, it has Q for K code words, then the K is the dimension. If it is a linear code, other code I cannot say that. So here this is 1, another is 1, 1, 0, 1, 0. This is my basis elements. For this code, this is my basis elements. So for generate C equal to alpha times this one plus beta times this one. Alpha beta belongs to F2. That is set to 0, 1. So you can check it if you write alpha. F2 contains only 2 symbols. One is 0, another is 1. If you write 0, 0, you can get the first code word. If you write 1, 0, you can get the second code word. If you put next 0, 0, 1, then 3 you can get. 1, 1 means you can get fourth one. So all linear combination of this one. Now I can write a matrix, one matrix. This is my matrix 0, 0, 1, 1, 1. This I have written as a matrix. The basis I have written as a matrix. First row is the first basis element. Second row is the second basis element. Right? So I have written this one. It's a linear combination only. You can write alpha times this one plus beta times this one. You can get the result. Alpha beta is either alpha beta belongs to 0, 1. 2 symbols, right? 2 symbols. So this is the things. So this is the matrix form. So this matrices I am going to call the generator matrix of the code. This matrix is called the generator matrix of the code. So if we know the generator matrix, we can find code. If we know the generator matrix, we can find the code. Because it's linear combination only C. It's linear combination only C. So here from graph, how can get a matrix? One matrix we need, that going to cut. Either we can the graph theory, there are 2 matrices. I know that. One is adjacent matrix, another is incident matrix. Adjacent matrix we cannot do much, but incident matrix we can do better. So for that, yes, graph everybody knows. That too, South Tamil Nadu, almost all the people know the graph theory. Even UG, BG you may study. So graph means a vertex set, another edge set. Edge means there are 2 ends, vertices. So for example, x comma y is a vertex, we denote x, y is a edge. If there is a edge between the x and y. So another is the incidence matrix of the graph. Cardinality of V by cardinality of V. The incidence matrix you see here, just let me give the example. E1, E2, E3, E4 are edges. One, 0. Just I have written, right? Is it right or wrong? Don't worry. So I have taken a graph. This is my vertex 1. This is my vertex 2. I have taken 2 vertex. The vertex V1 is, these 2 are incident. If it is incident, we can write 1. If it is not incident, we are writing 0. That means V1 is not incident with the E1, therefore I have written 0. V2 is incident with the E1, therefore I have written 1. If it is incident, we are writing 1. I can write E1, E2, etc. EM, edges, vertex 1, vertex 8, vertex N. If Vi incident with the E1, we can write 1, otherwise 0. Otherwise 0, that's all that one. Wij is jth edge is incident with ith vertex, then we write 1. Otherwise 0. That's all. So you can see that matrix contains either 0 or 1. Each edge incident with 2 vertices. Therefore, you can see here, if you take this column, there will be 2 place 1 1, because each edge incident with 2 vertices. Maybe this E1 may be incident with here and here. Other places may be 0. E1 is incident with Vi, Vj. So 2 place 1 1, other places are 0 0 0. So you can see that every column contains exactly 2 ones. Other places are 0. So immediately, this is a matrix with the 2 entries 0 1, right? So the 0 1 is 0 1 of cardinality F must be greater or equal to 2. If it is a group or ring, it may contain exactly 1 or less, not less, greater or equal to 1. But field means even in more than integral, if you take the cardinality must be greater or equal, if you take integral domain or more than that, the cardinality must be greater or equal to 2. So every field contains 0 1. You can ask me over where, because V is vector space over where, some field. Similarly, here base cut is edge connectivity or vertex connectivity. We study the minimum cardinality of an edge cut, that is this one. That is not at all necessary. Yeah. Here there is here definition by Bower. He has started the graph theory. How to find the code from the incidence matrix. Bower has given the definition. This is a graph, connected graph with the incidence matrix G. Then he says that the rows, what is the dimension? Because we have V1, V2, etc. Dn, but this generates a space, subspace. But these vectors are need not be linearly independent. The vectors, the rows are need not be, the collection of rows are need not be independent. So if it is independent, then you can say the dimension is n. Otherwise, dimension is less. He proved that if the graph is connected graph, then the dimension, the number of rows is, the dimension of this is not V n minus 1, dimension 1 less. If it is the vector space over F2. Otherwise, if prime is, I can take this Q, instead of Q I can take P prime. If it is a odd even prime, the dimension of the linear span of this space is n minus 1. If I can take P not equal to 2, P is a prime, P not equal to 2, then the dimension of the row span space is exactly equal to dimension of the cardinality of V, when if comma is not pipe-parted graph. If comma is a pipe-parted graph, then the dimension of the row span is n minus 1, the cardinality of V minus 1. If it is pipe-parted, otherwise it is exactly equal to V. So these things are standard result. So dimension we can find. The very important parameter of the code is, I told you, the minimum distance. If we know the minimum distance, it will correct d minus 1 by 2. Codes are fine to correct and detect the error. Detect the error, if possible correct the error. So how many errors we can correct, that is the very important one. So minimum distance is very important one. So for that things, we have taken some of the graph. Unit graph, zero divisor graph, that you, maybe graph theory researchers may know that. That is ring we have taken. U of R is a unit ring. The elements are unit. R is a finite ring. If 2 belongs to 2 is a unit, then the graph is a regular graph with the degree cardinality of UR. If 2 is unit, previously not unit, if it is a unit, then the degree of each vertex is either cardinality of unit or minus 1. So using this one, we have find out the graph ZP, I have taken prime. ZP. If P is a odd prime, then the incident matrix is number of vertex is this one, edge is this one. This you can find out very easily. We have given one example. So this matrix, the generator matrix of this one generates this course. This is a unit code. So here edge connected. So this code that you can see here, this is my unit. Let me say unit device cell code. You see here ZP1, ZP I can call it. What are the units of, what is the unit of a ring? What is the definition of unit of a ring? What is the definition? Unit? Multiplicative inverse is a unit, right? You cannot find 3 up to 5. Z6. Here units are 1, 5. There are 2 units. Others are not a unit. Others are not a unit. So is an edge. So P minus U, that alone 1 minus 1. Others are P1 minus 2. Then you can do it this one. This the number of degree you can find. This is number of edges. From this graph we have find out a code of length P1 minus 1 square by 2. The dimension of the code is P1 minus 1. The minimum distance is P1 minus 2. You can ask me, is it a good course? We cannot say that all the codes are good codes. We are trying to find out the good codes, right? At least we can find 10 codes or 100 codes. One of them must be good code. That is more than sufficient. One of my friends used to say that if you go and teach the students, you don't expect 100% will get everything whatever you are going to teach. Some of them may understand. Some of them later they can understand. Some of them they may ask the brilliant student, they will get it different things, right? So similarly, the processor we are trying to find out the good codes, right? But some of them may be good, some of them very bad, right? So like that, some of the graphs will give the good codes. Let me give one example. This is, I have taken my ring is Z5. So number of vertices is 5. Using this one, this many edges, the graph is, this is the graph. You can see here, 0, there is a edge between 0 and 1. 0 plus 1 is a 1, it is a unit. 0 plus 2 is a 2. I told you ZP, every non-zero element is a unit. So 0 plus any number is a unit. Therefore, there is a edge between 0 and all other vertices. If we take 1, there is a additive inverse, unique additive inverse, 1 there. There it cannot go. So remaining, it will go there. So 1 additive inverse is minus 1. It will not go here. It will go another 3 places. So each degree is 3 or 4. Exactly 1, 4, others are 3, 3, 3. So this gives the generator matrix. This is the incidence matrix. This is the incidence matrix of the graph. So this generates this code. This 8, the code length is 8, dimension is 4, the minimum distance is 3 over 2, binary code. Similarly, another one, if there we have taken ZP prime, instead of prime, we can take 2 prime, then we can get a code. This one, it gives a code. This is the code for this graph. This graph gives this code. The example is this one, right? This is this one. Another is over. He has given very good result in there. If you wanted to know the code from the graph, you will just type the Hover graph. He has published many papers. He has given many results, very good results. You can easily understand also. So just I give the things. Okay. This is notation. The code exists. Everything is there in the paper. You can see here with this Cartesian product, they are taking as here vertices of the graph. So the edges they have given us some definitions. Using this incident matrix, we can get a course. Some of the course. This is the graph. This gives the parameter of the code. Parameter means length, dimension, the minimum distance. Not minimum distance. This length and dimension will give. So we have find out some of these things. This I have taken from here. Some of the theorems using those code words. We got very good course. These are some references. You see here, if you wanted to know coding theory, the first two, these are books. The first one is very basic book, anybody can read and understand. Second book also I cannot say very difficulty, but it is good book. It is like a Bible in the coding theory persons. These two are, you can find out in the e-copy also in the net. These are some of the journals related to the graph. These are some of the papers related to incident matrix, code from the incident matrix. Okay, thank you. Anything? Few questions you may ask. You can ask me some, even basic also okay. Any questions? You see, don't worry about Sir may not know the questions. What we are going to ask, Sir may be thinking something else like that. Huh? If you know, you can ask. If I know, I will tell the answer. Otherwise, I can tell to some other person. They will communicate to you like that. I can say that. Don't worry about I know or I don't know or do other things. Okay? Anything you can ask me.
Communication media changed a lot as you said in the earlier speech. From landlines to phone to the 6 and now it is 5G. What about the phone system? Whether this had to be changed a lot or not?
Yeah. Sir asked me that. The olden days we have communicated through cables and a trunk call and the other things. We have taken communicate one message from one place to another place. It has taken half day, 1 day like that. So later, so Sir is asking that. So the code, the system of communicating the codes also is it changed or not? You see that there is a one language Tamil. It is standard one. So using that language, we are trying to communicate better. That's all. Codes are same things. So we are trying to find better codes. Instead of using the olden days, they may say that one particular code, this is very good code. Then later, better than this one is available. Like that. That way we can develop it. It is developing. Because previously they are used only two symbols 0 and 1. Nowadays you can see that United Kingdom for telephone they are using the 11 codes. 11 code means they are using 11 symbols. If the phone call even you did one mistake, it will least bother. It will go to correct person. Even if you do one mistake, it will go correct person. So like that they are coming the advance. Now still the people are using 0, 1 only, right? Very few are trying to use the other things, but it is developing. Because the problem on the government side, scientists side, there will be no problem. They have given the very good result. But the implementation side, it is a problem. Implementation is taking time on the problem. That's all, nothing else. Anything? Okay, thank you very much.
Gratitude is the memory of the heart. With grateful heart, I welcome Dr. S.P. Nandini, Assistant Professor, PG and Research Department of Mathematics, SFRC, to deliver the vote of thanks.
Good evening to all. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start my giving glory to the Almighty God for making today's occasion a resounding success. First and foremost, I would like to express my profound thanks to college managements, principals, head of the departments, and organizing secretaries of all three institutions for their support, valuable suggestions, guidance and encouragement in all our efforts. Next, I thank our distinguished special guest, Dr. C. Durairajan, Associate Professor, Department of Mathematics, Bharathidasan University, Trichy, who despite his busy schedule has found time to grace this occasion, and for his wonderful, mind-blowing lecture on the topic Codes of Instant Matrix of Graphs. We learn new research ideas like mathematic transformations of codes, Hamming distance, vertex and edge coordinates, and edge connectivity of unit graphs, and generator of Bower graph. Thank you, sir, for your inspirational lecture. I am happy to express my special thanks to all the faculty for their kind cooperation and coordination in all the essential deeds. Last but not least, I thank and appreciate the research scholars, students, coordinators for their help, support and assistance in making this session such a resounding success. Thank you.